and welcome to my lesson on convections and weather patterns for the heat unit of a grade 7 science classroom. Let us begin. Let's do a little quick recap about what we spoke about in the last lesson. We talked about the changes of state, and now we're going to apply it to weather patterns. As you can see here, when the three changes of state that are affected by the particle theory, which are liquid, gas, and solid, when they change state, there are various terms that are used for them. For instance, when solid changes to liquid, that is freezing or solidification. Liquid to gas is evaporation, and gas to solid without going through the liquid phase is sublimation. It would be very feasible to review these terms before continuing, as they are very beneficial to know for the rest of the heat unit. So what exactly is convection? Let's look at a few examples to get you thinking. Here we can see the warm and cold air surrounding a radiator. As you can see, the warm air travels downwards and the cool air continues to go upwards. Okay, something to think about. In the second and third example, we still see hot air going upwards and dispersing amongst the clouds and cold air going downwards. And finally, in the third example of atmospheric convection, we see hot air still rising and there's cooler air, cool residual air resting up here. All right, something to get you to think about as you try to figure out what convection is. I'm going to be giving you a few cues to be writing so that you know when to fill in the blank slides that we have in front of you. They're going to be obvious, blatant examples, such as this very exciting cue. So when you see the exciting cues, please fill in the blanks. So really, what is convection? Convection, as we know, only happens in liquids and gases. This is due to the fact that in a solid, the particles are so dense and so tightly packed that there isn't much room for movement, so convection cannot happen. Because, as you can see, the definition of convection is that convection occurs when particles are warmed up in liquids and gases, so the particles of the liquids and the gases, and they travel upwards, so they experience a rise. That's excitation, okay? Because there's heat, the particles are excited, and when the excited hot particles travel upwards, they eventually cool while they're up there because they can't stay hot forever, and the cold particles, which are much more dense than hot particles, fall down because they're weighted and they drop to the bottom, at the top to the bottom, and eventually where they get heated up again and rise upwards again. As you can see, that's a cycle. It's a cycle of hot and cold air circulating. So I provide an example here of convection in our everyday use. This is water being boiled in a pot, and the convection cycles, there's three arrows here showing you the convection cycles occurring. The hot air, which is that's produced by the hot particles closest to the flame, travels upwards to the top of the water where it gets cooled down and eventually gets more dense and drops back down to near the flame so it gets heated up again. So a few examples of convection are in the atmosphere, in the weather around us. On the road when you're driving, for instance, as in the small highway that you can see here, the ground, which is very hot because the sun is beating down on it all day, will warm up the particles near the ground, and those particles will travel upwards towards the sky where there's cool air. And when all those particles get cooled down and get heavy and weighted down, they will fall back down to the ground where eventually they are heated up again and travel upwards. Another example is in our homes. When we have a radiator system or another heating system that heats up our homes, as you may have noticed, it's a lot warmer in the upper floors than it is closer to the basement. This is because all the air that is heated up by the radiator travels towards the ceiling. Okay, it's nice and light because the particles are lighter. They travel towards the ceiling, so that's as close to the top of the house as possible. And eventually, when it gets cooled down, because it cannot stay hot forever, it will cool down to a more moderate level, so that's in the middle ground, so let's say that's in the living room, and eventually it will get really cooled down and dense, and it will travel back to the basement where it will find the source of heat again. So as you can see on the side here, the temperatures are indicated that it is a lot hotter towards the top floor, the ceiling, where it's 24 degrees Celsius, than it is at the bottom, where it is 18 degrees Celsius. And this is a heat gradient. Get ready to write! Oh, here is a band that I'm sure you may be very familiar with, One Direction. So again, prompt to write. How does convection happen in weather? Convection currents are also known as thermals. And the local weather, as we know, so for instance, the weather that we experience here in Ontario can be affected by bodies of water that are far, far away, such as in Asia even. Because as we can see, when you're closer to the water, it's going to start driving convection currents to be stronger and thus create wind currents. So the cool air travels towards the ground, while the hot air will travel towards the water. And then there's a reverse in the cycle pattern at night. So keep writing. During the day, the land heats up more quickly. Would you like to fathom a guess why? Well, that's because the sun is out. So when the sun is out, it helps out with the heating process just a bit. How does the wind know where to go? The heat travels in a very specific pattern. Well, how do you think the heat travels? Do they get on a plane? The Miami Heat gets on a plane? Well, that's a bit of a basketball example. In all seriousness, how does the real heat in the weather travel? Heat moves from warm areas to cold areas in the environment. So as you can see here, if you were to have an example of a contained area with two gradients of temperatures, all the heat particles are moving from this hot area to this cold area. So do keep that in mind, that the specific pattern that the heat likes to travel in is it moves from hot areas to cold areas. Knowing this, let's talk about the weather. Since the air on top of a body of water, for instance, let's talk about Lake Ontario, the air on top of Lake Ontario is cooler than the air on top of land, so the land beside Lake Ontario. The hot air from the land will travel towards the air on top of the water because it's traveling from hot to cold. Okay? Let me just reiterate that one more time. The hot air that's being heated up on the land is going to travel towards the water and float on top of the water because there it is a lot colder. That area is colder. While this is happening, all that cold air on top of the water now, okay, because it's getting cool, will travel towards the land where it gets heated up. And thus the cycle continues. So here's the more, let's talk about it with the display, ignoring the lighthouse, of course. The hot air on the land, as you can see here, is being heated up by the sun. When it's heated up, it rises because the particles get lighter. And the lighter they are, and being the hotted particles that they are, they're attracted to cold areas because that's the pattern in which heat travels. It travels from hot to cold. And due to the fact that this area on top here is cooler, and it stays there, all that hot air is staying there, it gets cooled down, and eventually because it is cooled down, it turns heavy and it drops down because it is denser. All this dense air is attracted and blown by the sea breeze to the land where it will get heated up again, and the convection patterns travel and occur again. And that's how the specific pattern of wind occur. What happens, though, when convection goes really, really wrong? Because it's all nice and dandy when you have your hot air, your cold air cycles, and they're working symbiotically to help each other out. But when convection goes really wrong, some natural disasters can occur. Is it when someone gets heated up and set on fire, like in the Hunger Games? Not likely. When convection patterns in the weather goes really wrong, it can form a tornado. Now, as I mentioned, hot air is nice and light, and it will travel upwards, where it will get cooled down, it get heavier, and eventually fall downwards. But what happens when this balance is pushed out of order? So, for instance, all that hot air that is rising, if it rises way too quickly, it's a rapid rise of hot, humid air, and that it can't cool down in time. Okay, it's spiraling quickly upwards, and the cool air cannot keep up with it to balance it out. There's a tornado. So as you can see here, the tornado, in case you missed it, the hot air is traveling up so rapidly, but it's not dropping down fast enough for it. So as you can see, it can go up to 40,000 feet in height. Now that's pretty scary and destructive to our environment and the world as we know it around us. And of course, there are other weather natural disasters that involve the convection of heat, such as, for instance, when convection patterns happen near a body of water and spirals very quickly, a tsunami or a hurricane can occur. I invite you to please research into another weather natural disaster that involves heat convection, and we can discuss it next time. Thank you very much for listening to my presentation on heat, convection, and weather patterns, and I hope you have a wonderful day.